The perpendicular height AB of a tree is 10 meters. A wire 14 meters long is attached from the top of the tree A to a point on the ground C. Let's read that again. The perpendicular height AB of a tree is 10 meters. A wire 14 meters long is attached from the top of the tree A to a point on the ground C. And here we have this diagram. And here what they want us to do is they want us to calculate to 2 decimal places the distance BC. And notice that we have BC right here. And this is actually a right angle triangle. And so let me just indicate that by using this pen. And so I'm going to indicate it by putting a box here. So this is a right angle triangle. And we need to find out what is this missing side. Now we know what is this side. This is 10 meters. And we know what this side, this is 14 meters. In fact, this side is the hypotenuse. All right, so it's going to be C. All right. And this side is one of the sides of the right angle triangle, and we're going to call that A. And the missing side, we're going to call B. All right. That's the side that we do not know. All right. We don't know the measurement of it. We don't know the length of it. And we can use this useful formula, Pythagoras theorem, which says that C squared is equal to A squared plus B squared, where C is the hypotenuse. And C here is 14 meters. And so we're going to put that there. C is 14. And A, well, A is 10 meters. And so A is right here. And B, well, B is the missing side. And so B is right here. And so we have 14 squared is equal to 10 squared plus B squared. And so what we have is we have 14 squared, which is 14 times 14, which is 196. And that's going to be equal to 10 squared, which is 100, plus B squared. We send 100 over the equal sign. And so when we send it over, it becomes 196 minus 100. And so we have B squared is equal to 96, because 196 minus 100 is 96. Next, we take the square root of both sides and we cancel this with that. And so we get that B is equal to the square root of 96. And the square root of 96 is 9.79795897. And so what we have to do is notice that they say they want us to write the answer correct 2 decimal places. And notice that we have 7. And so since we have 7, we have to, once it's 5 or greater, we add 1. And so we're going to add 1 to this 9. When we add 1 to this 9, this becomes 10. And so this becomes 0. And the 1 goes on top of the 7. And so this becomes 7 plus 1. And 7 plus 1 is 8. And so what we eventually have is a 9.8. And we eliminate all of the other numbers at the back. And so we have that B is equal to 9.8. And so that means that BC, the distance BC, is 9.80 meters. And so that's what this one is. Next, it states calculate to 2 decimal places the angle of elevation of the top of the tree from C. And so they're referring to this angle right here. And so what we have to do is we have to label our triangle. So this right here is theta, right? This is the angle C. And the angle that's opposite to theta is the opposite side. I'm sorry, the side that is opposite theta is the opposite side. And the side that is opposite the right angle is the hypotenuse. So this is the hypotenuse. And the other side is the adjacent. So this is the third side. Now we have to use one of these trig ratios. Notice that we have all 3 of the sides. We have the opposite, we have the adjacent, we have the hypotenuse, which is 14. And so we have the lengths of all of the sides, but I want to use the lengths that are given. And so since 10 meters is given and 14 meters is given, let's use those 2. And so this one is the hypotenuse and this one is the opposite. And so that means we have to use sine, because sine deals with the opposite and the hypotenuse. And so we're gonna use that particular trig ratio. Now we could use any trig ratio for this one because we have all of the lengths of the triangle. but I want to use the lengths that are given. That's just a safer route for us. And so we have the opposite, which is 10 meters, right? We have the opposite, which is 10 meters. We have the hypotenuse, which is 14. And we're trying to find what is theta. And so what we have to do is we have to take sine inverse of both sides, sine inverse of this, sine inverse of sine theta, and sine inverse of 10 over 14. This cancels out, so this cancels with that, and so we get that theta is equal to sine inverse of 10 over 14. And sine inverse of 10 over 14 is what? That's going to be 45.5846914. So sine inverse of 10 over 14 is 45.5846914. And so that means that the angle of elevation is this. But before we finish or before we move on, we have to round this. We have to write it correct to 2 decimal places. And so we have the 4 here. And since we have this 4 here, notice that once it's 5 or less, we cannot round up. And so what we have is we have 45.58, and 45.58 is theta. And that's going to be angle C, correct to 2 decimal places. 45.58 degrees, and that's angle C. Next, we have this question here. They said that a bird perched at A flies 16 meters in a straight line to land on the ground at D. BCD is a straight line. Calculate the distance CD. All right, so what they want us to do is they want us to calculate this distance. They want us to calculate CD. Like, what is the length of CD? Now, in order to answer this question, this is how we're going to do it. What we are going to do is we are going to find out what is the length of BD. All right. Now, once we figure out what is the length of BD, we are going to take that length, BD, and we're going to subtract it with the length BC. What is the length BC that I'm talking about? We're going to subtract it with this length, the length BC. And when we subtract that, or when we remove that 9.8, we'll be left with simply CD. And so that's the idea. We're going to figure out what is the length, the entire length of BD, and then we're going to subtract this length BC, all right? We're going to subtract 9.8. And so that's what we're going to do. And so what we have is we have to use, and now we're going to look at this triangle right there, this big right triangle. So let me highlight it, right? Let me highlight it. So we have AD, right? We have this right here, and we have this. So we're really referring to this particular big triangle, the big one. And so that is what we're looking at. All right. So let me do it better than that. So we have, let's highlight it. So use a different color. So let's use, say, yellow. And so we're really looking at this right angle triangle right here. Now, what side lengths do we have? Well, if you notice carefully, we have this side, this is 10 meters, right? We have this side, this is 10 meters. We have this side, this is 16 meters, all right? But we do not know what is the length BD, all right? We don't know what that length is, all right? And so that's what we're trying to figure out. And so in order to do this, we're going to use Pythagoras theorem. And Pythagoras theorem says that C squared is equal to A squared plus B squared. Now, what do we have? Well, we have C, right? We have the side C. This is the hypotenuse. This is going to be 16. So that's C. All right. We also have A, right? So this is A right here. A is 10. All right. But what we do not have is B. And B in this case is going to be all of this. All of this is going to be B. All right. So this BD is B. All right. And that's the missing side. That's the side that we do not have. All right. And we have defined it. And so we could use the Pythagoras theorem to do that. So remember that C is 16. So let's substitute that in. C is 16 and A is 10. All right, so that's this side right now. And so we have 16 squared is equal to 10 squared plus b squared. So what we have is we have 256. So 16 squared is going to be equal to 256. And 10 squared is going to be equal to 100 plus b squared. So we have 256 is equal to 100 plus b squared. What we're going to do is we're going to send the 100 over the equal sign. And when we do, this was positive 100. When we send it over, it becomes a negative 100. And so we have 256 minus 100. And so 256 minus 100 gives us 156 equals to b squared. And the next thing that we're going to do is we're going to take the square root of both sides. When we take the square root of both sides, this cancel with this. And so we are left with b. And b is equal to the square root of 156. And what is the square root of 156? The square root of 156 is 12.489996, and that is what b is. So b is going to be equal to 12.489996. But we're not done because we're trying to find CD. All we did was we found BD. That's all we did. And so in order for us to find CD, we have to take 12.489996 meters and subtract it with 9.80 meters. And when we subtract it, we get 2.689996 meters. But we have to write this correct to two decimal places. Notice that this is 9 here. Once it's 5 or greater, we could round up. So we add 1 to 8. And when we add 1 to 8, we get 9. So this is going to be 2.69 meters. And that's our answer, 2.69 meters. So the distance CD is 2.69 meters. And that's our answer for this question.